Hi all, welcome back. So now we are on chapter 5, which is on comparing investments or comparing projects. So these are the topics. Today we will focus on the net present value and the internal rate of return. Okay, two very common ways to evaluate projects is by using net present value or internal rate of return. And these two are two methods under the category of discounted cash flow procedures. Okay, let's understand what it is. Net present value of an investment or contract or business project is basically present value of inflows minus present value of outflows. So we will get the present value of all net cash flows. So it's quite simple. If you write it in a formula form, it will be as such: present value of all inflows minus present value of all outflows. So the concept is quite simple. I think the most challenging is to decide on the interest rate that is involved in this equation. So the appropriate interest rate is going to be one, cost of capital. Cost of capital means for a project we usually put initial investment, right? We fork out and put a sum of money to start a project, and then this initial investment will eventually generate some income rising, right? So the initial investment usually have a cost to it, cost of capital. So the cost can be, if the amount is borrowed by a bank, from a bank, then it is the borrowing rate. If it is an injection from a shareholder will have some expectation on the project for the initial investment, etc. So that is the concept of cost of capital. Interest preference rate is basically just preference rate of the shareholder from for this project. Like just now when I say the shareholders expected rate of return, this is something along that line. Interest preference rate. Opportunity cost, basically if you are investing your money into this project, you are losing some opportunity to invest in another project. So what are the return that you could get from the other project that we are losing out if we are investing here? However, we have to bear in mind the alternative project have to be similar level of risk, so that it's going to be reasonable for us to use for this project. So after we compute the net present value, how do we interpret that output, the net present value? If the amount is a positive amount, basically it is saying that it is okay for us to invest in this project because it will make profit. Our outgo will eventually be covered by all of our inflows. Negative means we should reject this investment because it will be a loser. Our income will not even cover our outflows. What if you have alternative projects? We have project 1, project 2, project 3, all you have calculate a net present value. The highest will be a better investment. Okay, this one, just to understand what is the meaning of the different choices of the interest rate that we use to calculate the net present value. What if the I is 0? This is an extreme case. This means that we are not even allowing for time value of money. So if we fork out 1,000, as long as we get back our 1,000, doesn't matter if we get back that 1,000 in 100 years time, 1,000 years time, it doesn't matter. As long as we get it back, then we are saying this project is viable. So this is not very realistic. What if our I is too high? What if we are using an infinity I? This is also very extreme. This means that the value of any income that we get tomorrow is 0. It doesn't have any value. So this project will never make a net present value of a positive. That is an extreme case. But what if our I that we choose is higher than reasonable? So if I is too high, it means same. the income that we get in the future, we are putting it too low of a value. So we are being too strict to ourselves when we are evaluating this project. What if we use the I, that is a market's risk-free rate? While our current project that we are evaluating usually will have some risk related to it. We are undervaluing our expectation from this project. So due to this, it is going to be very easy for us to achieve a positive net present value. So basically we are being too lenient in our evaluation of this project. So, this is an example of the calculation of NPV. First project, we lend $1,000 to Ted, and then Ted repays $500 in year 3 and $800 in year 8. So this is our outflow and this is our inflow. So the net present value technically is the present value of all of the inflow minus the present value of the outflow at the chosen interest rate, 4%. So our net present value is 29.05. Next investment is we invest 1,000 to Paul. Paul repay 550 in year 3, 720 in year 8. Also at 4%. So same method, present value of inflow minus present value of outflow, you get 15.04. So which one is a better investment? Of course, when we are comparing, we take the higher NPV. So investing to Ted give us a higher NPV of 29.05. Okay, now let's move on to internal rate of return, or we also call it as yield rate. What is internal rate of return? To solve for internal rate of return, we build this equation of value, which says that present value of inflow is equals to present value of outflow. So in other words, what is the interest rate that will give us a net present value of 0, or what is the rate of interest that will make our present value of inflow equals to net present value of outflow. So for example, this is the investment that we gave to Paul. So this is the equation of value. So net present value is equals to 0, right? So what is the I? Solve for the I to solve this equation. So if you see here, it's quite hard to use numerical method to solve for this. If the polynomial involved is, let's say, degree of 2 at most, then we can use the quadratic formula, right, to solve. But with a more complex polynomial, it will be harder to solve. So that's why usually it is solved by using machines like Excel, GoSig, or financial calculator, or maybe we can also use an iterative process. I will show you an example later. Okay, so let's see an example of a project. So this project, it have a cash outflow of 5,000 at time 0, and then it have a series of inflow for 6 years. So we are given the interest rate is 6%. So what is the NPV? So very straightforward. You just find the sum of all of the present value of the inflow and outflows, right? So you sum this all up, you'll get the net present value, which in this case is 2,209. What is the IRR for this project? What is the I that can make this NPV equals to 0? So we use GoSig. So we get 17.406. With a yield of 17.406, this project will break even technically. Example of an iterative process. Okay, for the loan we give to Ted just now, we know with 4% it will give an NPV of 29.04. So what I will bring the NPV to 0, right? So we need a higher I. So by trial and error, we try NPV for 5% is what? So when we try NPV for 5% is negative 26.61. So 4%, 5% I. NPV here is going to be positive 29.05. Here is going to be negative 26. So to get an NPV of 0, the I have to be somewhere in between 4 and 5%. So this is where we use the linear interpolation. We assume it to be straight line. So I that will give the NPV equals to 0. So when you solve for this linear interpolation, you get I is equals to 4.52%. So this IRR is accurate 2 decimal place if we calculate it in this way. Okay, calculation of IRR actually can also be done with our financial calculator. Here I attach a YouTube video for you to see how that can be done. Personally, to me, I would just prefer using Excel and using GoalSeek because the steps for this using financial calculator is quite long. However, you can try yourself and see which one would you prefer.